Alright, so I'm going to talk fast and make this short and sweet and simple. You might have to pause it so you can write and re-listen to it and things like that. But otherwise, you just got to try and get all these terms defined. So a point is an uppercase letter. And so example, you'd have A, and so you'd find A on a line. Right, going from side to side. Then you have a line is two capital letters. For example, you could have BC with a line above it. That means B and C. This line goes through and is continuous through both of those. That's why they both have a line above them. You name a plane with three capital letters. So if I had a picture like this, and I had D, E, and F down here, then I could say this is plane D, E, F. Notice D and E are on the same line, but F is on a different line. That's why that still works. Collinear are points that are on the same line. So that'd be A and B and E are all collinear. But if C was down here, then C is on a different line and not on a line at all, so it is not collinear. Okay, so remember, down here, you should see non-collinear. So points that don't form a line. This C is non-collinear. So then if I go back and we talk about coplanar, coplanar are points that are on the same plane. So if I look up here, D, E, and F are all on the same plane. If I put like an A out here, then A is not on the same plane, so then you can just scribble that out. Let's look at intersection. Intersection is the point where two lines cross, right? So that's just the intersection. Segment. So that is like AB. So that means it has endpoints at A and at B. So it is a line with two endpoints. Between, in the middle, 2 points. In the middle, for lack of better words, we did this with the distance one. So we would probably say B is between A and B, then or A and C. So then what we'd have is we'd have A on one end, C on the other. We draw some type of picture with B in the middle. So then if we're doing a problem like this and we have 3x and 17 and, I don't know, 38 as the whole thing, AC, you gotta do 3x plus 17 equals 38. Okay, and a lot of that comes from the beginning. What I did there was segment addition. That's the part plus part equals the whole thing. So that's what I did in this little example. These two pieces in green had to add up to be the whole distance 38. And then congruent segments. All right, remember, this is our congruent segment right here. You also got to remember that they'll have A to B, and we'll have C to D, and they'll put that little symbol in the middle. They'll put that symbol in the middle. That means these two pieces are equal. And so you got to be good at setting things and knowing in geometry what pieces are equal. So that is most of chapter 1. Alright, then we had some more things on your quizzes like distance formula. So if we scroll down to distance formula. Alright, distance formula. I'm just going to give you this equation. x2 minus x1 squared plus y2 minus y1 squared. Key things to remember. A negative 7 squared is always a positive 49. Negatives are always positive in distance formula, so make sure you're paying attention to that. And we're going to use that with 2 points. Midpoint formula, we're going to have x2 plus x1 over 2, y2 plus y1 over 2. This problem everybody should get right because you can graph and check. Alright? So you should be able to check midpoint and make sure those are equal. Now a segment bisector is going to cut a line segment into 2 equal pieces. Remember, those bisect words mean to cut into 2 equal pieces. A ray has 1 endpoint, while 1 continues. So while 1 continues, in other words, if I have AB with a line above it, in my brain, that means it starts at A and goes through B. It continues on and on forever. That's why they add that arrow in there. Opposite rays are where one ray starts in the middle and goes left, and one starts and goes right. Okay, what that does when you have opposite rays is if we had labels here like E, D, F, we would have said things like D through E is opposite D through F. And we also would have said creates a straight line. Then we have straight lines, so we got to know a lot of things about 180 degrees. I'm going to get rid of this stuff. So pause it if you need to write this down. The next thing we have is an angle. An angle is important because we have to know how to describe angles. So if I were doing this, I'd probably draw an angle. Alright, so angle. Use 3 letters to name. So for example, I would say that this is angle NMF. Sides of an angle. So sides, they have to be raised. So for example, that is M, N, and I draw my arrow through it, and the other one starts at M and F. So I'm looking at the outside, M through F and M through N. Vertex of an angle. vertex is always going to be the center point. So it's going to be, literally on my notes it says always the center point. So for example, that's going to be M. Interior of an angle. So interior of an angle is going to be all this stuff in here. So on the inside of the angle, inside of the angle. So for example, that is point D right now. Exterior of an angle, that's just outside of it. Outside of the angle, example, let's put another letter S up there. So we can put S up here, that's on the outside of it. Degrees is just going to be our unit of measurement. Unit of measurement for angles. So we're just going to use degrees of our unit of measurement for angles. Alright, and we're just going to keep trying to get through this. Chapter 1's got the most definitions because that's when we started geometry. So a right angle. Right angle, you need to know that is exactly 90 degrees. Acute has to be less than 90 degrees. Obtuse has to be greater than 90 degrees. Angle bisector is going to cut an angle into two equal pieces. So once again, if I said this is an angle bisector, this guy, this is going to cut it into two equal pieces. So if I have 2x and 40 here, 2x has to equal 40. Because that's what happens when you have an angle bisector. Congruent angles are going to be angles with the same measure. Alright, so usually they're marked congruent. They might have a little dash through it. I did the green in the angle bisector there. Adjacent angles are technically adjacent just means next to, so they're angles that are next to each other. So they share a side. They share a side. So I would say this angle in blue and this angle in blue are adjacent because they share this bisector as a side. So that's how they become adjacent angles. Linear pair has been my favorite thing all year. Two angles that make a straight line. So you gotta know they make a straight line. So add together and equal 180. Vertical angles. If I go like this, X, that's an X, that's a Y, this is an A and a B. So vertical angles, angles straight across from each other, angles straight across from each other. In other words, angle A is congruent to angle B, and angle X is congruent to angle Y. If I use that picture up there for the rest of my linear pair, angle A is plus angle X has to equal 180. Or angle A plus the one underneath, which is Y, has to equal 180. So then I know that I gotta get B in here, so angle B plus angle X equals 180. and angle B plus angle Y equals 180. So there are 4 linear pairs there. There are 2 vertical angles. So you just got to get good at recognizing which one it is we're talking about you finding. I'm going to erase this. Then we got like 5 terms left, and you can take a break from chapter 1 if everything would erase. Alright. So now we got complementary angles, and we did some in the review the other day. These are angles that add up to 90 degrees. Supplementary angles that add up to 180. So we worked on that vocab a little bit. Perpendicular lines are lines that intersect at 90-degree angles. Their slopes equal opposite reciprocal, OCAL. That means if I have -5/2, the opposite reciprocal to that, OR, is going to be 2/5. So you have to know what an opposite reciprocal. Symbol for perpendicular is going to be in green here. They just do a little T, upside down T. And then angle addition. You have to know that if I give you this angle in red, and we cut it in half with this, what they want from angle addition is they want you to know that you can add the 2 small angles, so the blue and green angles together to equal the whole red one. The whole red angle. So they want you to know that you can add the 2 smaller together, and that'll equal the bigger angle there. Alright, thanks for listening. That's chapter 1.